Atomic structure, first year chemistry topic, up to Rutherford's atomic model. That means from the beginning, subatomic particles, fundamental particles, discovery of fundamental particles. Next one, electromagnetic spectrum, wave parameters, wavelength, frequency, velocity, wave number, as well as problems based on the wave parameters and based on electromagnetic spectrum. In this class, we are going to discuss about Planck's quantum theory. To explain the black body radiation, Planck's proposed Planck's quantum theory. What is meant by black body? Black body is a perfect emitter and perfect absorber of all types of radiation. So, black body radiation was explained by Max Planck. Black body radiation was explained by Max Planck. According to Planck's quantum theory, the radiation is due to vibrations of charged particles. The radiation is because of vibrations of charged particles. The energy emitted or absorbed by a body is not a continuous process. The energy emitted or absorbed by a body is not a continuous process, but it takes place discontinuously in the form of small packets, called quantum. In the form of small packets called quantum. So, to explain the black body radiation, Max Planck proposed Planck's quantum theory. According to Planck's quantum theory, the radiation is due to vibrations of charged particles. The energy emitted or absorbed by a body is not a continuous process, but it takes place discontinuously in the form of small packets called quantum. The quantum energy is directly proportional to frequency of radiation, is directly proportional to nu. E is equal to h nu. Here h is nothing but Planck's constant. H values are 6.625 into h values are 6.625 into 10 power minus 27 erg second, or h is equal to 6.625 into 10 power minus 34 joule second. The quantum energy is directly proportional to frequency of radiation. E is equal to h nu. This is one of the formula. Here h is nothing but Planck's constant. The values of h, 6.625 into 10 power minus 27 erg second or 10 power minus 34 joule second. But we know that the frequency of radiation nu is equal to c by lambda. Then E is equal to hc by lambda. That means energy directly proportional to frequency but inversely proportional to wavelength. But we know that wavelength lambda is the reciprocal of wave number. Lambda is equal to 1 divided by nu bar. In nu bar is nothing but wave number. Then E is equal to hc by 1 by nu bar. Now E is equal to hc nu bar. That means energy directly proportional to wave number, energy directly proportional to frequency, but energy inversely proportional to wavelength. So E directly proportional to nu, directly proportional to nu bar, but inversely proportional to wavelength. So E1 by E2 is equal to lambda 2 by lambda 1 that is equal to nu 1 by nu 2 that equal to nu bar 1 by nu bar 2. The energy is propagated in the form of wave. The energy is propagated in the form of a wave. So energy is emitted or absorbed by a body is not a continuous process. The energy emitted or absorbed by a body takes place discontinuously in the form of small packets called small energy bundles, small energy packets called quantum. The quantum energy is an integral multiple of wavelength or integral multiple of frequency. So integral E is equal to NH nu. Here N is nothing but N equal to 1, 2, 3, 4 and so on. If N is equal to 1, E is equal to H nu. If N is equal to 2, E is equal to 2H nu. N is equal to 1, 2, 3, 4 and so on are number of photons emitted by the number of photons emitted per second. So E is equal to NH nu or E is equal to NHC by lambda or E is equal to NHC nu bar. Number of photons emitted by the bulb per second. Number of photons emitted by the bulb per second is equal to 1 divided by energy. Actually, 1 joule is nothing but 1 watt. You have to remember. 1 joule is equal to 1 watt. Energy is in electron volt. We have to calculate energy in electron volt. 12375 divided by wavelength in angstrom units. Important formulas. Energy in electron volt. 1237 divided by wavelength in nanometer. Wavelength in nanometer. These are the formulas based on the Planck's quantum theory. So, according to Planck's quantum theory, the energy emitted or absorbed by a body is not continuous, which takes place discontinuously in the form of small packets called a quantum. E is directly proportional to nu. E is equal to H nu. This is one of the formula. E is equal to Hc by lambda because nu frequency is nothing but C by lambda. But we know that lambda is equal to 1 by nu bar. So these are the formula number 1 and this is one of the formula. Next one. All these are the important formulas based on the Planck's quantum theory. Is equal, here N is nothing but number of photons emitted by the bulb bar maybe per second. N is nothing but number of photons. N is equal to E by H nu or E is equal to NHC by lambda or E is equal to NHC nu bar. If energy in electron volt, 12375 by wavelength in angstrom. If wavelength in angstroms, we have to calculate energy in electron volt or maybe nanometer. Then you have to observe. We have generally one is a CGS system, next one is a SI system. The energy is in erg. The units of energy in erg. The units of energy, we have to calculate energy in ergs. Then C must be velocity of light. C is equal to 3 into 10 power 10 centimeter per second. Wavelength must be in centimeters. Wavelength must be converted into centimeters. If wavelength is given, we have to find out energy. Then formula. If wavelength is given, we have to find out energy is equal to Hc by lambda. So C, if energy is in erg, C must be in centimeter. Wavelength must be converted into centimeter. H is equal to 6.625 into 10 power minus 27 erg second. Suppose we have to calculate energy in joules. We have to calculate energies in joules. Energy is in joules. We have to calculate energy is in joules. Then the value of C is in meters. 3 into 10 power 8 meter per second. Wavelength must be converted into meters. H is in joule. 6.625 into 10 power minus 34 joule second. Then we have to remember 1 joule is nothing but 1 watt. All these are formulas based on the Planck's quantum theory. Now, we will discuss a few problems based on the Planck's quantum theory. So, 1, threshold frequency. So next question, this is important model, listen carefully. A near ultraviolet photon of 300 nanometer, a near ultraviolet photon of 300 nanometer is absorbed by a gas and then re-emitted as 2 photons. So this is a metal surface. We have to pass. A photon is having wavelength 300 nanometer. This is incident light. 300 nanometer incident. When light of 300 nanometer passes over the surface of metal, it emits 2 photons. This is photon number 1 and this is photon number 2. It emits 2 photons. 1 photon is read with the wavelength 760 nanometer. Then we have to find out wavelength of second one. We have to find out wavelength of second one. We have to find out wavelength of second one. So we know that E is equal to energy incident. Energy incident. Energy incident is equal to energy of first photon plus energy of second photon. But we know that energy inversely proportional to wavelength. So 1 by lambda incident is equal to 1 by lambda 1 plus 1 by lambda 2. Okay. Energy of incident equal to energy of first photon plus second photon. But we know that energy inversely proportional to wavelength. 1 by lambda incident equal to 1 by lambda 1 plus 1 by lambda 2. 1 by lambda incident 1 by 300. 1 by 300 is equal to 1 by lambda 1. 1 by 760. 1 by 760 plus 1 by lambda 2. Now, 1 by lambda 2 is equal to 1 by 300 minus 1 by 760. So 1 by lambda 2 is equal to 760 minus 300 divided by 3 into 10 square into 76 into 10 power 1. 760 can be written as 76 to 10 LCM, you are taking LCM. So now 1 by lambda 2 is equal to 760 minus 300. 0 means 0. 6. 460 divided by 3 6 18. 3 7 21 plus 228 into 10 cube means 0 0 0. Here cancel. 2 2 2 8 2 1 2 1 2 4 0 0. 2 14s, 2 5s are 10, 2 7s are 14, 0, 0. So 14 by 5700. So 1 by lambda 2 is equal to 14 by 5700, whereas the lambda 2 is equal to 5700 divided by 14. 14 4s are 56. 14 4s are 56. Okay. 100, or maybe suppose, wait for a simple calculation, 5700 divided by 14. 2 7s are. Now 2 2s are 4. 2 8s are 16. 2 5s are 10. Okay. Now lambda 2 is equal to 2850 divided by 7 4s are 28. 7 7s are 49. So nearly 496, but not 49. Wait. 2850. 7 4s are 28. 5 0. 7 7s are 49. 7 4s are 28. 0. So, a near ultraviolet photon of wavelength 300 nanometer is observed by a gas and re-emitted as 2 photons. One photon is having wavelength 760 nanometer. Wavelength the second photon we have to find out. Okay. Now, E1 is equal to, in energy of incident equal to E1 plus E2. 1 by lambda incident equal to 1 by lambda 1 plus 1 by lambda 2. So 1 by 300 is equal to 1 by 760 minus 1 by lambda 2. Okay. Now, 1 by lambda 2 equal to 1 by 300 minus 1 by 760. So just you have to observe the calculation. Energy is inversely proportional to wavelength. Energy inversely proportional to wavelength based on that. Just you have to observe the calculation. 760 minus 300 by 3 into 10 square into 76 into 10 power 1 now. Okay. 7 6 are 42. 7 9 are 63. Now 496 into 7. 7 6 are 42. 7 9 are 63. 67. 96. So approximately its value is 496 nanometer. 7 4 ja 28, 7 9 ja. So if it is taken as 0, 50, 7 7 ja 49, nearly 7. But here option, as per the option, we have to take second one. A 1 kilowatt radio transmitter operates a frequency of 88 Hz. How many photons per second does it emit? 1 kilowatt radio transmitter operates a frequency of 880 Hz. So, already we know that 1 watt is equal to 1 joule. 1 kilowatt is equal to 1 kilojoule. That is equal to 1000 joules. One watt is nothing but 1 joule. One watt is nothing but 1 joule. 1 kilowatt equal to 1 kilojoule, that is equal to 1000 joules. Energy is equal to H nu. E is equal to 6.625 into 10 power minus 34 into 880 into 10 power 1. For approximate calculation, we have to take 6. Then E is equal to 880 into 6 into 10 power minus 33. 6 8 ja 48. 6 8 ja 48 plus 452. 528 into 10 power minus 33 joule. Number of photons emitted is equal to 1000 divided by power of the bulb divided by energy. 528 into 10 power minus 33. It can be written as 1 by 528 into 10 power 36. 1 by 528 into 10 power 36. So 528 1.00000. 528 1 ja 528. Option is based on the 1. So we have to observe there are 3 options are there. Fourth option is based on 1.7. Second also 1.7. 1 also 1.7. Go for next one. 2, 7, 4. Again 0. 7 ja. 7 8 ja. 56. 8 5 is 40, 6 56. 7 2 is 14 plus 5 19. 7 5 is 35 plus 1 36. 8 8 is suppose 528. 8 8 is 64. 8 2 is 16 plus 6 22. 8 5 is 40 plus 2 42. So maybe 8. Wait a minute. So 528. Right now 2, 9 lone 7, 4, 0, 8 8 ja 64, 8 2 ja 16 plus 6 22, 8 5 ja 40 plus 2 42. So this is 6, 9, 4 again 0. Now it becomes, I think, 9 and 5 is 45, maybe 0. So 0.00189 into 10 power minus plus 36. Okay. Now 1, 2, 3. 1, 2, 3. It can be written as 1.89 into 1, 2, 3, 10 power 33 photons. So option becomes the fourth. 1 watt is nothing but 1 joule. 1 kilowatt equal to 1 kilojoule. I am taking approximate calculation. Hence here we got 1.89. But the power you have to observe. If suppose you have to take here 6.625, then it must becomes maybe 1.7. Don't worry. 1 kilowatt equal to 1 kilojoule, that is equal to 1000 joules. Energy equal to H nu. 6.625 into 88. So approximately I am taking 6. 88 into 6, that is equal to 528 in 10 power 30 minus 33. Then it becomes 10 cube and 10 power minus 10 power 36. So this is the correct option. What is the potential energy of electron? The concept is not over. An atom moving a speed of 600 with accuracy. This is Heisenberg uncertainty principle. Threshold frequency. Now, the energy of photon is 3 into 10 power minus 12 ergs. What is the wavelength in nanometer? What is the wavelength in nanometer? Now, first we have to write the formula. E is equal to hc by lambda. We have to find out lambda. So, lambda is equal to hc divided by E. Lambda is equal to H value 6.62 into 10 power minus 27 into 3 into 10 power 10 divided by energy is given 3 into 10 power minus 12. 3 cancel. 10 power minus 12 becomes, then lambda is equal to 6.62 into 10 power minus 27 into 10 power plus 22. Now lambda is equal to 6.62 into minus 27 plus 22 means 5 into 10 power minus 7 centimeter. But we have to find out wavelength in nanometers. So 10 power minus 7 centimeter is equal to 1 nanometer. So here that is not 7. 27 minus 5 here. 10 power minus 5 centimeter. So 10 power minus centimeter equal to 1, minus 7 centimeter equal to 1 nanometer. 6.62 into 10 power minus 5 centimeter is equal to how many nanometers? So therefore, wavelength is equal to 6.62 into 10 power minus 5 by 10 power minus 7. It can be written as 6.62 into 10 square or 662 nanometer. So option 1 is correct. E is equal to hc by lambda. We have to find out wavelength in nanometer. Lambda is equal to hc by nu. This is the formula. So lambda is equal to 6.16 10 power minus 27 into 3 into 10 power 10 by 3 into 10 power minus 12. 3 cancel. 10 power minus 12 becomes a positive. Minus 27 plus 22 means minus 5. 10 power minus 7 centimeter equal to 1 nanometer. 6.16 10 power minus 5 centimeter equal to. Then this is 662. 662 nanometer. A photoelectric effect. Electromagnetic radiation is having threshold energy. This is also photoelectric effect. What is the energy of photon corresponding to wave number? Wave number is given, we have to find out energy. What is the energy of photons that correspond to wave number? So E is equal to hc nu bar. Energy is in ergs. So E is equal to 6.625 into 10 power minus 27 into 3 into 10 power 10 into wave number is given 2.5 into 10 power minus 5. Now, energy is equal to the product of 6.625 into 3, 19.875 into 875 into 2.5 can be written as 5 by 2 for easy calculation into minus 27 minus 10 means minus 17, minus 17 minus 5, 10 power minus 22. Okay, now if it is approximately taken as 20, 2 1 ja, 2 5 ja, 5 5 ja 25. So E is equal to 25 into 10 power minus 22 erg. So we have to do exact calculation because option is not here. So now wait a minute. So now E is equal to 6.625 into 3 into 5 by 2 into 10 power minus 22. Okay. 2 3 ja 6. 2 3 ja 6. 2 1 ja 2 2 ja. Now E is equal to 3 2 ja 6. 3 1 ja 3. 3 3 ja 9. 3 3 ja 9. 9.936 into 5 into 10 power minus 22. Now E is equal to 5 6 are 30. Okay. 5 3 are 15. 15 plus 3. 18. 5 9 are 45. 40 plus 1. 46. Now 5 9 are 45. 45 plus 4. 49. So 49.680 into 10 power minus 22 only. We are getting same answer. So 49.680. Okay. Into 10 power minus 22. So approximately this is taken as a 5. So E is equal to 49.680 can be written as suppose 4.9680 into 680 into 10 power minus 21. This is approximately taken as 5 into 10 power minus 21 erg. So this is the correct option. Okay. So E is equal to hc nu bar. H means Planck's constant, 6.625 into 10 power minus 27 into 10 power 3 into 10 power 10, 2.5 can be written as 5 by 2. Minus 27 minus 5 minus 32. Minus 32 plus 10 means minus 22. So 2 3 ja, 2 3 ja, 2 1 ja, 2 2 ja, 3 2 ja 6, 3 1 ja 3, 3 3 ja 9, 3 3 ja 9, 5 2 ja 10, 5 1 ja 5, sorry, 5 6 ja 30, 5 3 ja 15 plus 3, 18, 5 9 are 45 plus 1 46. 45 plus 4 49. 49.680 approximate 4.9680. This is a 10 power minus 21 approximately 5. This is the calculation of energy when frequency when wave number is given. Which of the following may relates both the photon as a wave motion as well as stream of particles? According to Planck's quantum theory, the energies emitted or observed by a body which is in the form of quanta, whereas Einstein, the energy emitted or observed by a body is in the form of small packets called as nothing but a photon. So E is equal to h nu. E means energy packet. H E nu frequency. Frequency explain the wave parameter, that is wave nature of electron. So E is equal to h nu explain the both the wave motion as well as a stream of particle. So E is equal to h nu explain the both the wave motion as well as stream of a particle. The work function of. So this is Planck's quantum theory. Now we are going to discuss about photoelectric effect. Listen carefully. Photoelectric effect. Photoelectric effect. Okay. Now, what is meant by photoelectric effect? This is a metal surface. There is some of electrons present on the metal surface. When light of suitable frequency passed over, when a light of suitable frequency passed over metal surface, electrons present on the surface of the metal takes up energy from the incident radiation and ejection of electron takes place. The phenomena is nothing but photoelectric effect. The electron emitted is called as a photoelectron. The electron emitted is called as a photoelectron. The process is nothing but photoelectric effect. Generally, due to large atomic size, small ionization energy, alkali metals are having higher that means they are a good metals. They can be used in making a photoelectric cells. Cesium is the best metal. Which is used in photoelectric cells. What is meant by photoelectric effect? The process of ejection of electron from the surface of a metal. The process of ejection of electron from the surface of a metal. When a beam of a light is having suitable frequency, may pass over the surface of the metal, the phenomena, the ejection of electron is nothing but photoelectric effect. The electron which one is ejected from the surface is nothing but a photoelectron. Okay. Now, E is equal to Ke plus W. Here, E means incident energy. Ke means kinetic energy of photoelectron. W is equal to work function that is equal to h nu naught. W is nothing but work function that is equal to h nu naught. Nu naught is equal to threshold frequency. Threshold frequency. Nu naught is nothing but threshold frequency. What is meant by threshold frequency? The minimum frequency that must be required. The minimum frequency that must be required for the ejection of electron. The required frequency is nothing but threshold frequency. The required frequency is nothing but threshold frequency. Nu is greater than nu naught. Incident frequency is more than required frequency, threshold frequency. Photoelectric effect takes place, and the photoelectron is having some kinetic energy. With some kinetic energy. Photoelectric effect takes place with the electron is having some kinetic energy. Nu less than nu naught. Threshold frequency is more than required frequency. Photoelectric effect does not takes place. Does not occurs. For example, the cost of book is 100 rupees. The cost of book is 100 rupees. Actually, we have 120 rupees. Cost of book 100 rupees. Which amount means we have 120 rupees. So we buy the book. There is no worry about that. Actual amount of cost of book is 100, but we have 120 means the required amount is lesser when compared with whatever the amount we have. Out of 100, but actually we have 80 rupees only. 80 rupees only means we are unable to buy the book because the cost of book is more when compared with whatever the amount we have. We have actually 80 rupees, but the cost of book is 100. It is not possible to buy the book because the cost of book is more when compared with whatever the amount we have. Okay, suppose the cost of book is 100, we have 100 only. So we can buy the book with a zero kinetic energy. That means if nu is equal to nu naught, if nu is equal to nu naught, photoelectric effect takes place with the zero kinetic energy. So, E means energy of incident radiation, Ke means kinetic energy of photoelectron, W is equal to work function, W is equal to h nu naught. Here nu naught means threshold frequency. Threshold frequency means the minimum frequency possessed by the metal. The minimum frequency that must be required for the emission of electron from the surface of the metal. The required frequency is nothing but threshold frequency. Nu more than nu naught, photoelectric effect takes place. Nu less than nu naught, photoelectric effect does not take place. Nu equal to nu naught, photoelectric takes place with zero kinetic energy. Now, kinetic energy of photoelectron depends on the frequency of radiation, but independent on the kinetic energy of electron emitted. Photoelectron depends upon the energy or maybe frequency of radiation, but kinetic energy independent on intensity of radiation or number of photoelectrons emitted. A graph drawn between kinetic energy versus intensity of radiation, or number of photoelectrons emitted, or photoelectric current, photoelectrons emitted. A straight line is obtained which is parallel to intensity axis. Even though intensity increases, but kinetic energy remains constant. That means kinetic energy of photoelectron emitted is independent on intensity of radiation or number of photoelectrons emitted, but kinetic energy depends upon the frequency. Now, number of photoelectrons emitted. Photoelectric current directly proportional to or depends on the intensity of radiation depends on intensity of radiation. Depends on intensity of radiation. Independent on frequency or maybe kinetic energy. Frequency or maybe kinetic energy. Number of photoelectrons emitted depends upon the intensity of radiation but independent on frequency of radiation as well as kinetic energy of radiation. So a graph drawn between intensity versus intensity versus number of photoelectrons emitted. Number of photoelectrons emitted or photoelectric current. A straight line is obtained which is passing through the origin. As intensity increases, number of photoelectrons emitted also increases. But intensity, number of photoelectrons emitted, the independent, do not depend on frequency or maybe kinetic energy. Now, E is equal to kinetic energy plus W. But we know that E is equal to h nu, W is equal to h nu naught. Now, h nu is equal to h nu naught plus kinetic energy. Now, kinetic energy is equal to h nu minus h nu naught. Okay. So, y is equal to mx plus c form. A graph drawn between kinetic energy versus frequency of radiation. Frequency taken in x-axis, kinetic energy taken in y-axis. Here slope is a negative slope. Sorry, slope is a positive negative intercept. Slope is a positive but c is nothing but intercept. C equal to intercept. So, slope is a positive like this. Here slope equal to h. Intercept is equal to minus h nu naught. Now k is equal to h nu minus h nu naught. Now k is equal to h into nu minus nu naught. This is one of the formula. Similarly, k is equal to h into c by lambda minus c by lambda naught. Now k is equal to hc by 1 by lambda minus 1 by lambda naught. This is one of the formula. But we know that kinetic energy K is equal to half mv square. So half mv square is equal to hc into 1 by lambda minus 1 by lambda naught. One by lambda minus 1 by lambda naught. V square is equal to 2hc by m 1 by lambda minus 1 by lambda naught. Now V is equal to square root of 2hc by m 1 by lambda minus 1 by lambda naught. Or V is equal to square root of 2hc by m lambda naught minus lambda by lambda into lambda naught. This is the mathematical forms and application means formulas for photoelectric effect. The best metal which is used in photoelectric cells is the cesium due to large atomic size or maybe low ionization energy. Generally, potassium, rubidium, cesium are used in photoelectric cells. Photoelectric effect means the process of the phenomena of ejection of electron from the surface of the metal. When a suitable frequency of light is passed or allowed over the surface of the metal. As energy, means the kinetic energy of photoelectron increases. Means energy of photoelectron increases, kinetic energy will be more than doubled. Now we